Are you interested in machine learning? One of the things that we need to do when applying machine learning to various domains is to create features. Typically, we want to have a lot of data if we're using machine learning, but often we want to take that data and apply our domain knowledge to create specific features that are derived from that data. Sometimes we'll call them analytics, other times we'll call them features, and the process of doing this is often referred to as feature engineering. In this case, we're interested in looking at transaction cost analysis, or TCA, and we're looking at creating some features so that we can apply machine learning to TCA in order to estimate the impact our orders may have on the order book. One of the key inputs to TCA, and specifically into a pre-trade market impact model, is what the trading strategy is. Often when we get data from our clients, we'll see information regarding the algorithm, which can give us an idea of what the trading strategy should be, but there's not always a great correspondence between the label that we get from the client and the actual trading strategy that interacted with the order books. From a pre-trade model development perspective, it's the actual interaction with the order books that's most important. So the question arises, can we use the data that we get from our clients to create features that will accurately describe a trading strategy? So here what we're going to do is take a look at some code. I'm using the R language, and the first thing I'm going to do is load a couple libraries. The first one is to visualize, and the next two are to apply analysis across several strategies at the same time. We'll set up the strategies so we can have a front-loaded strategy, which may be similar to an implementation shortfall with a high urgency. We can have a rear-loaded strategy, which might be something that's similar to a closing strategy. We might have a uniform smooth strategy, like a time-weighted average price. A uniform choppy strategy, which might correspond to a POV type strategy. We'll take those strategies and put them into a data frame. And then the next thing to do is to create the actual features. I'm going to do that down here. So I've got a data frame that I'm going to store the information in. I'm going to take the strategies. I'm going to group by the actual strategy, whether it's front-loaded, rear-loaded, uniform choppy, or uniform smooth. And I'm going to calculate what really amounts to the time-weighted unfilled portion of the order. So let me just do that here. And I'm going to go up here and I'm just going to plot that so that we can get an idea of what our trading strategies look like. So I've got that here. I'll just zoom in a little bit. Here we can see our front-loaded strategy, our rear-loaded strategy, a uniform strategy, which is choppy, meaning that these bars are different heights, and sometimes we don't have trades during certain periods. And here's our uniform strategy, which we're going to use as a baseline benchmark strategy, where we're doing a constant amount of volume as a function of time. These two strategies are highly asymmetric in time, whereas these two strategies are quite symmetric in time. So can we come up with some features that we can take these strategies and boil them down into two numbers? The first feature that we're going to compute is what we call the exposure, and we've done that here in our charts data. And the second one we can do is we can look at the difference that our charts have, or that our strategies have, with respect to how choppy they are. Okay, so what do I mean by that? Let's take a look at another chart. I'll just call that up. And in this case, what we're showing is the curve here is the what we call exposure. This is showing the portion of unfilled shares that are remaining in the order. The blue part here is the area under that curve, and basically what we're doing is we're integrating that and figuring out the time-weighted unfilled portion of the order. That's going to be equal to the area under the curve. So this is the front-loaded strategy. Here's our rear-loaded strategy. And here's the choppy uniform and the uniform smooth strategies. And I fit a line here. This line, this red line, corresponds to our benchmark strategy, which is the uniform smooth. So the second number that we can compute from this is we can subtract this blue curve from this red curve and compute the standard deviation. That's going to give us our choppiness. So let's put those two together. I'm going to just put that into a variable and we'll plot that. So we're going to plot it using this command. We'll show both of them together. And let me just zoom in a little bit here, make it easier to see. So now on the left, we can see here's the trading strategy, and here's our features. Now the actual features are the exposure number here, so in this case 0.1, and the standard deviation, that's the roughness. So that's when we subtract this line from this curve and compute the standard deviation. And we can see that this trading strategy has a low exposure and a fairly high choppiness. So the standard deviation of the difference of these two lines is 0.26, whereas the exposure is 0.1. This strategy, where we execute more shares at the end of the strategy, has a much higher exposure, but a similar standard deviation. Down here, where we have a symmetric strategy, the exposure number is much closer to a half, and the standard deviation is quite a bit lower. So it's about 0.06 as opposed to about 0.26. So 6% versus 26%. Now the uniform strategy, this is really the benchmark strategy we're using. So it's symmetric and has a choppiness of exactly 0. So what we've done now is we've come up with some features that we can apply to real orders using just executed volume. And instead of looking at the label to figure out what the trading strategy is, we can see directly how we interacted with the order book. Now, if we wanted to take this a step further, instead of using executed volume, we may also want to look at things like active volume versus passive volume, volume sent to lit venues versus unlit venues, volume sent to inverted venues, etc. But what we're trying to do in this video is just illustrate how we can reduce a large number of data points into a couple numbers that we can then feed into a machine learning algorithm. So in future videos we'll go and take those further steps, but I'm going to wrap things up here and show you how we compute features for a trading strategy. Thank you.